The next topic that we can discuss here is the replica management. So as we have seen different consistency models, right? The solution, so when you have multiple copies of the data stored available, maintaining the data in a consistent state itself is a big challenge. But replica management is a solution for a solution for what you call improving the performances, right? So now, how do you do this replica management itself? So the key issue for any distributed system which is supporting the replication is, so they have to decide when you tell replica management, the data store itself is replicated and placed in different locations so that the performance is improved, right? So now, how do you decide? So we have the important issue is to decide where, when, and by whom this replicas, the replicated data stores should be placed. Okay, so this decision of where to place the replica, right? When I have to decide whether when to do, okay, now the state is, the request is high, so let me replicate the data store so that some request is transferred to that replica, right? So how will you decide when I should make a copy of the data and whom, right? So by whom this replica should be made, right? So these are the important decisions to be taken when you are considering the replica management. So based on this, the placement problem is the place. So where to place, right? All those things, which is called as the placement problem. So where to place the server so that the efficiency is high, where to place the content so that you get the data responses made efficiently, right? So the placement problem is itself is split into two parts, right? So that is one is the replica server itself, the placing of replica server. The next placement problem is placing of the content, right? So these are these based on these 2 points, we will be discussing the different ways of placing the replica server, how to place the content, right? So the difference is kind of, so when you tell placing of a replica server, so so here you will be finding the best place. So in this case, finding the best place, right? Or best locations where you have to place a server, right? Where you have to host a replica server, and so that the requests are taken care by those replicas as well, right? So finding the best locations is called the placing the, and decide like I will place a location, I will place a replica server at this location as the request from this area is high, right? So the placing of replica server means to find a suitable position location in the network to decide where to place that replica server. The next is placing the content. So this is actually deals with finding the suitable server, right? So since the servers are now in place after this step, so now which content has to be should be residing in which replica, right? So the content, the data, or the content itself has to be decided on which server this content has to be placed. So placing of the content means finding the best server, Okay, finding the best server for placing content. So these are the two aspects of the replica management. First, you will be finding the best location for the server itself, and the next is once the servers are in place, we will decide which data or which content has to be placed in which server. So you find the best server for placing the content. So in this category, now we will see the next topic, which is content replication and placement. So there are three different ways of placing the servers, so that you can see in the figure below, right? So you can see the innermost this thing as a permanent replicas, right? So you have a permanent replica, then you have a server initiated replica, then client initiated replica, right? Uh, so the outer radius is the clients. So that's three different ways in which replicas can be distinguished. So internal, you can see permanent, server initiated, and client. So in case of permanent replicas, so you have already, it can be actually considered as a backup mechanism, right? So the initial, you will be having initial set of replicas. So you have initial set of replicas already in place, right? So which will be in very few number. Okay, so you have an initial set of replicas maintained in default way. Then these set of replicas, so when you see in numbers, it will be very less. So number of permanent replicas are small. Okay. So now, so let's see with the help of an example, what is this permanent replicas. So for example, if we need to have a distribution of a website, okay. So the replication, we are starting with the replication. So now the website itself need to be distributed in different servers, right? So in that case, there are two ways. Example. Distribution of website. So in this case, it takes two forms. So one is like the files which constitutes the web page, the site itself are replicated. So the files that constitute the website are replicated to different limited number of servers at single location. Okay, so the files are replicated and it is in limited in number. It is replicated to limited number of servers at single location. Okay, so whenever a request comes in, it is forward to one of the servers, right? So now you have a collection of servers where the files which constitute the website itself is now running in the different servers. So when say different servers, the files are copied, say I'm labeling it as F, in different servers at single location, the files which constitutes a website is there. So when the request from the clients are coming in, say C1, C2, C3, etc., right? So now, so the requests are coming in to access the website. So these servers which are limited in numbers are given a chance for servicing that request. And if the requests are kind of a burst, so they all take a round robin way strategy for distributing the load, and that's how the replica here is taken care of. So that is one way of distributing the website. Another way here is mirroring. You would have seen when you are trying to download the website, it will try to connect it to a mirror website which is close to here, right? So here in this case of mirroring, the website is copied to a limited number of servers. Okay, so the website is copied to a limited number of servers. So as you can see, it is all for very small number of servers, permanent replicas. So these are called as mirror site. So here in this case of a file distribution, it is a kind of a single location, right? So all the servers will be of single location, and they round robin way, they will be distributing the workload and servicing the client request. In this case, mirror. So this mirroring will be done geographically, spread across. It's not in a single location. Okay, so that you can see the difference. So in case of mirroring, it is done in geographically different locations. It is spread across this mirrored websites, and here the single file will be distributed in multiple servers which are in a single location, right? So when there is these are the different ways in which you are distributing the managing the replicas with the help of a permanent replica style. So the important thing you have to understand is, you can see in the figure itself, it is of a small radius. So you can assume that the number of permanent replicas are always very small. So there are two ways. One is kind of copying the file, distributing the file containing the information itself in multiple servers, but the servers are residing in single location. Another one is mirroring, where the content is mirrored and it is geographically separated across multiple locations. Okay, so that is about the permanent replicas. Now coming to the server initiated. So the next category is server initiated. So in server initiated replica management, you can see the copies of data stored is mainly used to enhance the performance. Okay, so the main objective of server initiated is to enhance performance. Okay, so the copies of data stored, so you have multiple copies. So when you replica means you have the same, please keep that in mind. You have multiple copies of the data stored, and the copies are maintained in order to enhance the performance, so that the copies take the responsibility of servicing the request, right? Basically, in the case of a server initiated, they say the role or this is initiated by the owner of the data store. The decision of replication, right? So the data store owner will decide to replicate the kind of data store, to copy the data store, and to improve the performance. Basically, the key objective is to improve the performance. Okay, so now, for example, say you have a web server, right? So web server hosted the location, say some location in New York. Okay, so you have a web server hosted, which is located in New York. So in that case, and it is easy to service. So this particular server is providing some service, right? So to this service, a number of requests are coming in, right? So the request, you're getting the request to access the content here, right? So this particular server handles the request easily. Some set of that's the work of any kind of web server, right? So it handles a request very easily. But you can see for over a couple of days, say for a few days, we were seeing a sudden burst in the sudden burst of requests coming from a faraway location. So over a couple of days, you can see the request to access the web server is coming from some faraway location, and it is a sudden burst. Okay, so you're getting a sudden burst of requests from faraway locations. But the server which is having the content is in New York. So you can see that in this case, what is a so here the main idea of making the copy of the data store is to increase the performance. But when you see the burst, so the number of it generally handles the request easily, but you can see there is a sudden burst of requests, and that too which from far away locations to the server which is located in New York. Right. So in this case, what is a feasible solution is, so the solution would be, so it's worthwhile to, you have to install temporary replicas, right? So you will install a temporary replicas. So you're not sure if this burst is going to continue or not, right? So you maintain a temporary replica so that the performance is again enhanced or improved, right? So the request need not go this long to the location in New York. Instead, because the burst is high suddenly, you maintain a temporary replica which is very close to the region from where this sudden burst is coming in. Okay, so that's a way of replication. So this is actually, you can see, initiated by the server, because this server is maintaining the huge number of bursts, a huge number of requests. So it is now replicating and making a temporary replica which is close to the place where the requests are high. Okay, so this is the idea of server initiated replica. So in again, so in server initiated replicas, you can see, say for example, say client C1 and C2. Okay, so client C1 and C2 needs to access a file called F. So it sends a request to uh, P. Okay, so it sends a request to P here, right? So this so this is this P sending the request to P. Okay, so in when the P receives the request, you can see the P C1, both C2 are close to the server P. So they want to access the file F, which is residing. The file F is actually residing in server Q. Okay, server without a copy of file. So P is a server which does not contain file F. Q is a server which contains file F. Both client C1 and C1 and C2 want to access a file F, which is residing in Q. So the closest server is P. So you can see the dotted line. The C1 and C2 send the request to access file P. So this instead will be sending the request to Q. Okay. So every server maintains the list of access counts. Okay, so you have access counts. So this, in this case, each server will maintain an access count here, right? Access count and who is accessing, from where the request is coming. So in this case, so file F is to be accessed and it is coming from P. So though the request are two, the server Q will be seeing this as a single request coming from P. So server Q counts access from C1 and C2 as if they could come from P. So the Q understands that it is a single request coming from P. So, so that's a idea here. So here you will be maintaining a different to access the counts per file and where the access is coming from. Okay. So here in this case, as I explained, C1 and C2 is trying to access the file F. So based on that, you can see the value, the access single access count value. So you can see count value at server Q. This is from P and to access file F, right? So when the number of requests for specific file F, okay, at server S is kind of dropping. So you will be maintaining different values. So you have a deletion threshold called DELS, F. Okay, so this is called as a deletion threshold. So deletion threshold is decides so I'll just tell the parameters. So deletion threshold for file F at server S. Okay, so the file can be removed from S. So if the deletion threshold, if the access count or then the number of requests for a specific file F is less, so I'll just write request for F. Okay, so the count, the number of requests for F is less than deletion threshold. Okay, so deletion threshold is F, S comma F. So if it is dropping drastically, then what? So the file F can be actually removed from S. Okay, server S. You need not maintain that replica because the file is not being requested frequently, or the number of requests to that file is very less. So that file F can be dropped or removed from S. So you have to make sure, unless it is not the last file which is existing in the system. If that is the case, you may have to retain. So another such value, one more matrix here is you have the replication threshold called ReplicaManagement. So this is a replication threshold. So in this replication threshold, which is actually chosen as a higher than, so this replication threshold is going to be greater than the deletion threshold value. So what does this indicates? So the number of requests for specific file is so high. Okay, so it which is greater than this. So the number of request for F is greater than some replication threshold value, then it decides to it is worthwhile replicating it in another server, right? So the request for such a file F is greater, right, some than some threshold, then it is worthwhile that file can be replicated in the other servers also, so that the requests are distributed to load of serving the request can be distributed to multiple servers, and hence the performance is increased. right? So again, so these, based on these values, they take the decision of to replicate or to delete or to migrate. So if the value is kind of between deletion and replication threshold, then you try to migrate the file itself from one server to another. So all these things are decided based on the number of requests it is coming from. Okay, so that is about the server initiated replicas, and this are used mainly for say read-only copies which are close to clients. Okay, so next is client initiated replicas. So you can see in the figure initially shown, it is of an outer diameter. Client initiated replicas, right? So this is basically, we have seen this in several situations in our discussion. We basically tell that as a caches, client caches, right? When you try to access the website, it makes a local copy, and which resides when you further try to access the same web page or same content, it will not go to the request is not going to the original server. Instead, the request will be serviced by the cache. So the client cache actually does the temporary access a temporary store, which stores the information of the recent access that you are doing. So temporarily, it stores a copy of the information which that client is accessing. So if further such request is coming, in order to improve the performance, this the service is the service is answered by this local copy or the client cache. So again, the main advantage of this is to improve the access time. Right, the request need not go to the server, come back, get the response. Instead, from the local client cache itself, the service is answered. Right. So one problem, as you all know, is when you are accessing the stored cache local data, you are not sure if when it was last modified, like staleness, right? Whether you are accessing the recently modified data or you are accessing the old data, that all things are not ensured when you are trying to use the client cache. So there is the issue of this addressing the staleness. So here the client this has to invalidate whether you are accessing the correct data or not. Okay, so actually here you can see there are two ways. So we call, when you are trying to access when you are placing the request and it is answered by the local cache, then you call it as a cache hit, because which improves the access time, because your request is serviced at the maximum speed. So this when you are placing the request and it is stored in the local cache. So the other way is to maintain a separate machine itself, which that separate machine should be in the same local area network as the client. Okay, so there are two ways. So you have a client which is sending the request. So in the client itself, you have a local cache. Right, so this is a client, and when it sends an request to access some page, it is actually so the response is actually stored in the local cache, right? When further a request is made by the same client, the data from the local cache is retrieved to the client. So that is the idea. So this is the one way. So the client itself is maintaining a local cache. Another the second approach is like you have a set of clients in your system. Okay, in your network, you have set of client which is sending the request to be accessing some data. So here you are maintaining a separate machine itself, which is behaving as a clash. But the separate machine is actually present in the same network as the client is residing. Okay, so it's not going to be a machine which is outside. So which also will be improving the client's. So same local area network as the client is residing, a separate machine can be a dedicated machine for accessing the or storing the local cached information is maintained, and the separate machine is actually part of the same local area network as the client is residing. So these are the two ways in which you maintain the local copy. Again, the issues are the staleness, all those things are coming into place. So the placement here we are discussing is the placement of the client caches, how to place the cache, right? So we have seen here either the cache could be in the same machine as its client. So this is a single machine, same machine, you maintain a local cache for each machine. So that is one way, or otherwise a machine which is shared by all clients on the same network. So that is how the placement of the client caches are done. Thank you.